All right. Hey, how's it going, ladies and gentlemen? So, this is Mr. Payne, and what I wanted to do in this video is essentially go through. Hold on. Apparently, I can move that. Is essentially go through your guys' review, right? Go through your study guide. I'm not going to go through it 100% because I feel like, some of the problems are a little redundant once we get a little further into it. But I should have everything here open that we need to go through it and be successful. So let's take a look at this first section, the atomic symbol, reading an atomic symbol. So we have to always remember when we're looking at an atomic symbol that this letter right here, of course, is going to correlate with our element, right? Whatever element it is. So that letter is going to match up here on the periodic table. In this case, we're looking at element V, which is vanadium, right? So we're going to look at vanadium. Let's go back to our review, and with vanadium, we see this number down here, 23. This bottom number is always going to be the number of protons, and we can look back here at our periodic table, and we can see, of course, vanadium, right, has an atomic number of 23. Now, a huge thing you guys need to remember for this test is that the atomic number and the number of protons in an atom are exactly the same, right? It's how we count up the periodic table. Hydrogen has 1 proton. Helium has 2 protons. Lithium has 3. Beryllium has 4. And that is true as anything throughout here, right? We go here, we see iridium has 77 protons because its atomic number is 77. That should be crystal clear by now. Now, let's look back here. So, like I said, right, our atomic number, our first question is the atomic number. Well, of course we know that's the number of protons, or the number here in the bottom left, so 23. Now our mass number. Our mass number is something we're going to have to get from our atomic symbol as well. And remember, our mass number is protons, like this 23, with the added in neutrons. And if we take protons plus neutrons, of course, we're going to get 51, right? 51 is our mass number. So our mass number is always going to be there at the top. Number of protons, you guys should be able to get this lightning fast because, of course, we mentioned that the number of protons is equivalent to the atomic number, which we already decided is 23 right here. You can also find that on the periodic table up here at the very top, right? 77, or right here for vanadium again, 23. Now, the number of neutrons, this is going to actually require a little bit of algebra, right? A little bit of math. We know that our mass number is 51. We know that the mass number consists of protons plus neutrons. So when we look at the number of neutrons, we have to basically know that the number of neutrons is going to be equal, to the mass number minus mass number minus the protons. That's because, right, think of it as a pie. Half the pie are these 23 protons. The other half are going to be our neutrons. So, if this is the whole pie, the entire pie is 51, we need to take away our 23 protons in order to be just left over with our neutrons, right? So let's do that math, and I'll even do it. I'll do it through Google so you guys can see. So we take our mass number, which is 51, then we subtract 23. And of course, we're going to get Google's awesome with a calculator, 28. So we're going to see our number of neutrons is, let's highlighted, is 28. And of course, number of electrons, if we're in a neutral atom, we know that no matter what, number of electrons have to equal the number of protons. So that is a give me, right? It has to be 23 because we have 23 positive charges from the protons, 23 negative charges from the electrons. Put those together and they balance out to a 0 net charge. All right, good work. Let's keep moving on here. If we look here on this side, we see we have another 23 protons. Well, we actually can look at this, right? This number we know is the atomic number. So we go look at our periodic table, and we see vanadium is element number 23, right? Element number 23. So we know this is going to be a big old V for vanadium. Now, our mass number is a little different. We'll have to find that out later, but let's fill out as many answers as we can. If we look at our next question, It wants to know the atomic number, right? Well, that didn't change. It's still 23. We have 23 protons here. That's a given. Our mass number, well, we're not too sure. So let's move on and figure it out later. Number of protons, okay, that's good to know. 23, right? Because it's the same as our atomic number. We've decided that in our last problem. Now we're given the number of neutrons. And if you recall, let's look at our back example. Protons plus the number of neutrons is going to be equal to our mass number. Well, look at this. We're given the number of protons and we're given the number of neutrons. So we have to take 29 and add it to 23. Of course, we can go to our calculator if you prefer. 29 plus 23. What are we going to get? We get 52, right? 52 is our mass number. And we can fill that out up here as well, right? 52. And then again, of course, we know that the number of electrons have to equal the number of protons if we're looking for a neutral atom. So we're going to have good old 23 again. Now this one, I've given you nothing on the atomic symbol. If we're looking at our third problem, I've given you nothing in the atomic symbol, but I did give you the mass number and the number of protons. So we can actually go ahead and fill that out. So remember, our number of protons is always going to go here on the bottom. And our mass number is always going to go up here on the top. And once we figure that out, I mean, we're set. We can figure out the rest of these no problem. So in order to find out what element it is, we have to know our atomic number. And our atomic number is 25, or the same number of protons, right? So we go over to our periodic table, and let's count to 25. So we have, here's 23, 24. We have 25, element manganese, right? Element manganese. Where's my thing? Here it is. So that is going to be element Mn, manganese. Our atomic number, we just found out, right? We have 25 protons, so our atomic number is 25. Number of neutrons, we're going to have to do a little bit more algebra, right? We have to take our mass number, which is 52, and subtract out 25, and I'll do it in front of you guys. So we take our mass number of 52, that's neutrons plus protons, then we take out the protons, I forget how many we had, 25, and we're left with 27. So we know we have 27 neutrons. And of course, we now remember that we have to have the same number of electrons as we do protons in order to have a neutral atom, which is going to be 25 electrons. So I ask you a question, which of the above atoms are isotopes of each other? Now when we're looking at this, remember, isotopes are the same element, they have the same number of protons, but they differ in the number of neutrons, right? So if we look here, we only have two examples that are the same element. We have two things here that are vanadium, right? They have the same number of protons, so that checks out. And their mass numbers are different, which means they must have a different number of neutrons, considering they have the same number of protons, but different mass numbers, which means that difference must come from their neutrons. And we can look down here at their number of neutrons, right? We have one that has 28 neutrons and one that has 29. So clearly, the answer here would be yes. Not yes, sorry. Yes is correct. There are isotopes, but which ones? So we have the two vanadium. So you just say vanadium, right? Vanadium. How do you know? What is the same? What is different? Well, I'm not even going to write that out. We just talked about it, right? Our protons stay the same, so it's the same element, but the number of neutrons we have are different. Now I ask you a question, what are valence electrons? Valence electrons, recall, if we look at a Bohr model, valence electrons are always going to be electrons on the outest ring. So if we look here at nickel, right, you guys remember the element nickel, the metal nickel. We see nickel has two valence electrons because we go to this farthest out ring, ring number 4, and we see there's only 2 electrons here. We can even look at, where's another good one? Let's do this. So we have 9 protons and 10 neutrons in the atom fluorine. Its outermost ring right here, right? That ring number 2 has 1, 2, 3, 4, 5, 6, 7 electrons. So electrons, the definition, the valence electrons, these are just electrons on the outer shell. Electrons in the outer shell. And for how many valence electrons, let's actually flip over here to this page where I ask a few more questions, right? Remember, valence electrons are always going to be in order. So we have 1, 2, then boron is 3, carbon is 4, 5, 6, 7, 8. And that's true throughout the entire periodic table. So tin, right? Not tin, excuse me, titanium, or something like indium, right? They're going to have 3 electrons. Excuse me, that's not actually titanium. Titanium's over here. I misspoke. But aluminum, right? 3 electrons, valence electrons. If we look over here at oxygen, sulfur, selenium, beryllium, those are all going to have 6 valence electrons. It's true for the up and downs, right? So let's go back and answer our questions. How many valence electrons do the following elements have? Phosphorus. Well, let's go look at our chart. Phosphorus falls right here under nitrogen. And this family has 5 valence electrons. So our answer is literally just 5. Now let's look at Mg. Mg is magnesium. Magnesium falls right over here on the left side. It's one of our metals under beryllium. And beryllium has 2 valence electrons, which means the rest of this family has 2. So, right there, 2 valence electrons. Now chlorine, let's go ahead and check that out. Chlorine falls under fluorine, and this family has 7. So we'll go ahead and write in our answer 7. And then finally we have boron. Boron is right here at the very top of this boron family, and we have 3 valence electrons for that family. So there we are. I want to stop this video here. It's long enough. That's the answers to the first slide and how to do a lot of different calculations. To be completely honest, this will probably be the longest video. So if you feel good about it, you don't have to watch this whole video, but if you need to, hopefully it covers what you are confused about. I'll probably make a separate video covering this real quick, this section for a few minutes, but other than that, this is the bulk video for our test. So this is all slide 1. So if you guys have any questions, message me on Schoology. I should be releasing this probably Wednesday night, maybe Thursday morning. We'll have to see how I feel, but you guys are going to do great on the test, all right? See ya.